Okay, let's write down how the other sounds on a piece of paper and both flip them over at the same time.
Well, you sound terrific, like a millennial podcaster.
That's what I had on yours. That's what I had for you. All right, we're good. Everyone sounds good.
All right, perfect. Nailed it.
So here we are 20 years later, 20 years after we integrated DTrace in, it's amazing. Because you know what's amazing? Because I got married shortly after we integrated, Adam.
Yes, that is amazing.
It is. Okay, wait a minute. That wasn't. I don't think that's actually where I was going.
You know what? What I remember.
Like, you want to get something off your chest.
Well, what I remember is
that I actually managed to actually mate and
he's
spawn.
He's been holding it in for 20 years. To be fair,
I think you had both of these deadlines looming. Both involved a bunch of work. I remember someone at the time kind of commenting on it, and you saying that the DTrace deadline was much more stressful. I think sort of because the wedding was going to happen one way or the other. Like it didn't matter what kind of shambles it was. Like if everyone was getting takeout Hardee's or the Australian equivalent for dinner, like it was going to happen. As opposed to DTrace integrating, like it was only going to happen if it was done.
First of all, I believe the Australian equivalent would be Hungry Jack's. Josh, correct me if I'm wrong.
Now look. Hungry Jack's was a spin-off of Burger King.
Is spin-off the right word?
Well,
is that the word you're looking for?
There was a franchise licensing thing that happened because eventually, like decades later, the Burger King people showed up and started trading under their own name, and I feel like that caused.
Did Hungry Jack's go away?
I don't know that it went away, but it may have actually by now. Like they may have figured out how to fix all that up. But for a long time, it was Hungry Jack's, certainly.
And for an American in Australia, you're like, is Burger King aware of Hungry Jack's? This looks like
no. They definitely were because it was the home. It was our home of what you would call the Whopper. I believe we also called it the Whopper.
Yeah. What did you call it? I think you called it the Whopper.
I think it was the Whopper. I don't think there was anything substantially different about the menu.
I think the Whopper is actually. I think the Whopper feels like it's almost a name that Australia would come up with. I think you'd be very proud of the Whopper.
No, we'd call it the Whopper.
No, Whopper. Right, exactly.
Be less rotic R's in the.
Fair enough. So yeah, Adam, I thought it was going to be all Hungry Jack's at the wedding. Fine, who cares? Meanwhile, DTrace not integrating would be a real problem.
So you're saying one of these projects was date driven?
Pretty much. Did I verbalize this relative anxiety around Bridget? I can't remember if this was
but like around a lot of colleagues. And I think actually one of your helpful colleagues, not me, did mention this to Bridget, and she was like, absolutely, like date driven. The other one was quality driven. Look what I've ended up with.
I'd like to say we've been married for 20 years in October, so we're doing all right. We're doing all right.
Yeah, exactly.
DTrace and the marriage are both doing well, actually. Pretty amazing. So, I mean, it is amazing that it was 20 years ago because it still feels so recent. And I feel it's like we're really lucky to have software. I mean, how many people get to have 20 years of experience with their own software and get to look back and, what did we do right? What did we do wrong? What were some of the things we regretted? I don't know how many of those there are, but there are a lot of things we got right, actually. It was fun.
Yeah. And remarkable to literally still be using it and privileged to see it living on in systems that we didn't build. Every time I fire it up on my Mac, I feel very grateful that has continued in their, mostly true to the principles fork of it. And it's been great.
And you feel slightly less gratitude every time you have to go into SIP or whatever to go.
There is that. They're like, oh, good, a new update. Oh, like a new problem. Oh, I have to do the SIP dance to be able to use this thing again. There is that.
I am grateful.
That's right. Yeah. For those not familiar, Apple has DTrace and has had DTrace, and we'll get into that. But it is locked down in ways where you have to break a bunch of warranty voiding, glass in order to get your way there. But it's not so bad.
It's not so bad, and it is. And I think we feel very lucky to have a technology that people are willing to root their Macs to use.
Yeah, that's right.
It's terrific. So, how do you want to go? I think we wanted to reminisce a bit about some of those early days, for sure, and especially with like the things that kind of benefit from 20 years of hindsight, because there is a lot. I mean, it's actually we have had to extend it. We've had to rewrite remarkably little of it.
Mm-hmm.
Josh, when you say beetroot in the chat, is that a reference to? That's not a reference to beetroot. No, never mind.
No, we're still on Hungry Jacks.
Okay, you're still on Hungry Jacks. I actually this is where my brain went. Because Bridget and I met online. This was, but it was. I now know that this is how everyone meets. But this is, in order to, this was at a time when you couldn't see other profiles. Like you could only see, if you were a man seeking a woman, you could only see women, not men. So I wanted to scope out the competition. So I created a fake profile. Did I tell you this, Adam?
Yes.
Oh, I did tell you this. On one of the lab machines named Beak, and I had the account that I created. I'm sorry that you do this. This has really got nothing to do with DTrace, but it has a lot to do with getting married. So I'm sorry. We'll be here quickly. Then I'll get back in the car. So I created this account. I used the root account on Beak. I named this profile Beak Root. It was very important to me that it get no interest because I'm going to create basically a fake woman to see what my own competition was. And I wanted to be sure that this got no actual interest. So I wanted to create I didn't have to upload a profile photo. I basically didn't answer the survey questions, or the questions I answered with like just minimal amount of detail. I did have to put a height and a weight in there, which was in hindsight, like turns out it doesn't need any more than that to get an overwhelming amount of interest is what I learned. But I did need to put a tagline in there. It won't let you continue without an actual this little like one sentence synopsis. And Adam, do you remember this? Do you remember?
No.
So this was at the height of the .com boom. So I wanted to again make this revolting to any would-be suitors. So my tagline was Uber hip .comer seeks pre-IPO beau. And I mean, of course, like it all makes sense now. Like I got buried in interest. Like that thing got so much more interest than the actual like real me. It was a little bit like, okay, all right, well. And so I had people who were pouring their hearts out to this thing and they're explaining like what their vesting schedule was. And they're just like, oh my God, this is so embarrassing. Anyway, so yeah, sorry. When you said beetroot, I thought you were making a beetroot reference, Josh. Josh, I'm sorry if I burned you with this oversharing detail.
Actually don't think I've heard that story before. So that's
you don't have to use the word actually.
There we go. There's one. Brian, in terms of where we start on DTrace, not to distract you, but I'm not sure I don't know how broadly you've shared this, but I've always found it interesting, like where the idea from DTrace came from, because that was well before your time at Sun. As I recall, like some of these early ideas were from when you were an undergraduate.
Yeah, that's right. Well, I wanted in particular, and actually it's funny because I was just seeing someone on Hacker News experimenting with what you can do just with LD preload and how you can like load your own shared object, and you can interpose on an arbitrary shared object. And I wrote this little goober that I called Sift that allowed me to basically do what shared object interposition now does, and SOTRUS. Remember SOTRUS?
Mm-hmm.
And it was just shining a bright light onto like, oh my God, this is what the software is doing. And I just felt like there were, I was working on the trying to make sense of the end-to-end scheduling model, and what I realized is just like what the software was actually doing and what people thought it was doing were two very different things. And I'm like, why don't we have a better way of figuring out what the software is doing? The only way of figuring out what the software is doing is like putting a breakpoint in the debugger. Like, why do we do it that way? And why don't we? I just don't understand. I didn't understand why we don't dynamically instrument program text to when we want to understand what it's doing. And then once we understand what it's doing, uninstrument it and put it back, basically. And which doesn't feel like super deep thought, but I did ask our OS professor, at university about this, and he's like, yeah, you know, I don't know. I think there must be some reason that can't be done, because if they, this is like kind of important. He's like, this is like a reasonable thing. I didn't even question this at all. It's like, if you could do this, they would have done it by now. And I thought the same thing. I'm like, I think you're right. Yeah, there must be some reason that this is like impossible to instrument program text. And when I was interviewing at Sun and was talking to Jeff Bonrick and Bart Smulders, and I remember going to lunch with everybody, and I was coming back from lunch and kind of like, hey, there's this question of me to ask you, you know, why don't you do it this way? Why don't you allow program text either in kernel or in userland to be dynamically instrumented? And Bonrick was like, yeah, no, there's no good reason. Like, you should do that. We should do that. I'm like, oh, really? I just was not. I was so oriented to getting an explanation about why this was impossible, and there was this moment where he was like, "You should come here and do that." Like, yeah, you should come here and do that. That sounds great. And I try to remember that moment when dealing with anyone early in their career, asking why something isn't done some way, because it felt like so uplifting and empowering to be like, oh, I'm going to come here and do this. And that sounds great. And what I didn't realize was, well, you are, but there's a lot of actually like junk you're going to have to deal with first. I just felt like, from coming to Sun, I had an idea of like, this is what where I want to kind of orient myself towards. But there was just a lot that had to be done in the interim. And there was a lot that was just, so that was in 1996. And we didn't start DTrace until 2001.
Well, you didn't start it in earnest, but you were putting down a lot of foundation, as I recall.
That is,
like, you know, in particular, CTF,
yes.
but like also, you know, getting a lot of miles on the tires in terms of your experience with Solaris and debugging really complex performance problems.
Yeah, that is true. And so a couple of things happened that were important. So one, we had some really crushing performance issues, especially on these big systems, the E10Ks. And Jeff had done this really interesting tool in Solaris 2.6 called Lockstat. And Lockstat actually did use dynamic text instrumentation of just the synchronization primitives, and allowed us to understand what the synchronization, where we, in particular, when we were blocking why, where, for how long. And
just to pause, Lockstat is so fucking cool. And especially before we had built DTrace, when you start looking at the locking primitives and see that these handwritten assembly routines were built in such a way that anticipated this kind of dynamic instrumentation that you're referring to. They were built in a way where they say, replace this instruction with this other instruction, and then it'll fall through into this Xanadu of data collection.
Yeah,
and then
that's right.
Return the system back to fully functional, or pardon me, full speed, not fully functional. It was always fully functional, but rather to optimize performance.
That's right. And Jeff had actually done that. So when the synchronization primitives were originally written, that was not the case. And Jeff had rewritten them in 2.6 as part of doing the Lockstat work, if memory serves. So that's why it looks like it was always designed with instrumentation in mind, because it was rewritten with instrumentation.
Oh, yeah. I know. Yeah, of course.
And then that what ended up being really, really important, because it was our only way of understanding what was going on inside the kernel. And we had... but it was really limited visibility. I mean, you could only instrument this kind of like one very important but kind of thin layer of the system, namely the synchronization primitives. And you would immediately have follow-up questions that you couldn't answer easily. And so there was, in particular, and I remember this very vividly because it was my birthday, 1997, dealing with this very large E10K system, benchmarking system, that I hadn't really even seen an E10K. We didn't have one in software. It was way too valuable to give one to software. So this was an E10K that was running a gigantic SAP benchmark that General Motors was interested in. And it required actually 4 other E10Ks to feed it, which was...
Holy smokes.
Yeah, huge. And it took, this machine took like 2.5 hours to boot. And we knew that the system would enter prolonged states of deep, deep sadness. And we did not know why. And the only tool we really had was Logstat. And you could see during the periods of sadness that like we were in the networking stack. And I was writing modules. I was basically doing handwritten, unsafe DTrace. I was basically writing custom kernel modules and loading them, and then like effectively hot patching the system to jump into them. And it mostly worked, but occasionally didn't, and the system would panic, and then I would like go have 2.5 hours to reflect on what about all these points. Yeah, it was bad.
Nice.
And through that, the whole time I was thinking like this is a networking issue, and that wasn't totally wrong. In that we were ultimately like we were super sad because we were like order of n cubed in the networking stack. But like, why were we there, and why was it so transient? Well, as it turns out, the reason what was actually happening is the system had been misconfigured, and it had been misconfigured to act as a router. And
I forgot this. This is hilarious.
And there was a router elsewhere in the lab that was popping occasionally, and that thing would pop, and the E10K would be like, "You, I am actually the world's worst router. If you would like to, while this other lab router is out, I can."
do you want a DHCP lease? I can hand out.
I don't think I'm too busy. It's like no.
It's like, are you busy with anything? Any benchmarks you should be doing right now?
Right? Don't you have if you think really hard, like, don't you remember the SAP workload I just gave you? It's like, oh, that is ringing a bell. Maybe. You know what? I'm going to furiously route these packets in this terrible order of n cubed algorithm, and then which also explained why it would suddenly write itself, and then it would be. And I remember that moment was like very eye-opening for me about the idea that these things deep in the stack could actually be manifestations of very high-level issues where, a system has been, misconfigured or misadministered, or there's an application running that's a surprise. And the only way we kind of get to it is with these super deep symptoms. I mean, Adam, this is what I keep trying to get traction on Leventhal's conundrum.
That's right. The butterfly flapping its wings that you need to find that has caused the hurricane.
That has caused the hurricane. You have the hurricane. You need to find the butterfly, and which is still really hard. I mean, really hard. And but I think that became very eye opening. I'm like, we absolutely have to do this. And then the foundation that you're referring to was. So I had
well hold on before you take the next step. So that's 1997, which is before I got the Sun. Now, by the time I got the Sun in 2001, DTrace. I think you and Mike Shapiro, who worked with us on DTrace, also you guys had a notebook, like a DTrace notebook.
Yeah,
and when I got to Sun, DTrace had this sort of vaporware, you guys would wander into problems, and I don't know if this is actually true, but seemingly, and say, well, DTrace would solve that. And you had done that enough where people were like, all right, well, could you please just build it rather than telling me that the thing you have not built would solve my problem?
That's right. It had a Duke Nukem Forever kind of vibe. Or is it Halo 3? Am I using that right, Josh? Is that right? No.
Do you mean Half-Life 3?
Half-Life 3.
Oh my
God!
Look,
I'm sorry. I'm not a gamer.
All that fumbling is going to look great in post. We'll clean that all the way up.
Here on Discord.
Right, here on Discord. Okay, look. Half-Life 3. Right, I knew it was one of those things that the kids talk about. It had these kind of vibes of like the thing that is always coming, that you actually want right now, but does not actually exist, and you are being told that it will be. Don't worry, penicillin will solve this. Like, well, what are the penicillins? Like, well, we haven't really started on it. It's like, okay, well, yeah. And I did, Adam. You can, I'm sure, visualize this because I caught Tim Marsland, a former colleague, who very distinguished accents, English guy, and Tim was trying to debug a problem, and that had been really painful for him. And I did cheerfully volunteer, like, DTrace solves that problem. And he was so pissed off. He's like, DTrace solves that problem. Why don't you start implementing DTrace? Like, okay, right. Maybe we need to stop talking about the problems it's going to solve. Maybe
that's right. Enough with the hype, right?
Enough with the hype. And I did think that, like, I think that, this is also kind of another interesting object lesson about the way we structured the early approach. First of all, we knew that we wanted to get the DTrace. And I think the thing that you're referring to that was exceptional was that Mike had figured out a bunch of the foundational stuff that was going to be required, and that I didn't really fully appreciate the importance of CTF4 DTrace, which is our ability to get type information in the kernel. And Mike felt very strongly and justifiably so that type information should be available in the kernel itself, that you should not need to get some auxiliary file that contains the type information, that the system itself should have its own type information. And we needed that for MDB, but Mike also saw the need for it for DTrace, which I really did not appreciate at the time, honestly. And there were other things like this where he had a terrific kind of connected graph of all the things that were going to be required to get us to the point where we can even earnestly start on DTrace. And so we did a bunch of that work in the kind of 98, 99 timeframe, which I think is
this is like Solaris 8, Solaris 9.
Solaris 8, Solaris 9. Yeah.
Yeah.
But looking really for an opportunity to actually really start on DTrace. And I think that a lot of engineers feel this way, that especially when you become valuable to an organization, you feel like you're constantly being kind of caught up in the next crisis, and it can be hard to get out from underneath that crisis disposition. And you and I got caught up. Well, I got caught up in a crisis, and as I recall, I dragged you under with me. The Cheetah Plus mess. So Cheetah was a microprocessor, a very cruelly named microprocessor at Sun, because the thing was not fast, had a lot of problems. It was hot, it was late, it was slow, it was expensive. It had, other than that, it had a lot of problems. UltraSpark 3, and in particular, they had made a really grievous error where they had taken. So recall the TLB issue with Cheetah Plus, or with Cheetah. So they, UltraSpark 2, Blackbird, and so on, had a fully set associative 64 entry TLB, and then some number of those pages will be locked, but fully set associative for all pages. And what they had done is taken a bunch of instruction level traces from Sybase running on Solaris 2.4. Now, the year 2.4 comes out in like 94, maybe 93, and now it is 2000, or it's 2001. It's early 2001. Right. And so this is like a trace that is like 8 years old. But it shows you how long when they made this decision, it was arguably only like 4 or 5 years old, but the decision they made was the operating system isn't using large pages. So we should have a large TLB for small pages and a very small TLB for large pages. And the problem was we hadn't implemented large page support yet. And that support was implemented in the operating system after Solaris 2.4. So the data that they gathered was all basically wrong and was real. I mean, this is one of these things where it's like being more data intensive was actually the wrong thing to do. And what they should have done is like realize like, no, of course we are going to add large page support in the operating system. And of course you should support large pages from a large TLB. But what they did is they moved to a 16 entry fully set associative TLB for large pages, which is down from 64, and then a bunch of those ended up being locked. So you end up with like 5 of those being locked. So you end up with like this 9 entry TLB for large pages. Small pages, meanwhile, live out of a 512 entry TLB, but only 2 a set associative, which is also just death. So when your set associativity gets that, so I don't know, Adam, do you remember these workloads? Because this is on both the instruction side and the data side. So
you'd just be thrashing, right? And you'd be thrashing from compilation to compilation, depending on how the compiler laid out your code.
That's right. So you could easily have just a workload that is hitting like instruction, going through a plit and into a shared object. Like that's 3 different bodies of text you're going to execute in a pretty hot loop. And it's like, yeah, you get unlucky and those map to the same set. And like literally a shared object, by the time you got up there, you like evicted your program text that called it. And it was bad. You're like, why? Yeah. I'm like, every once in a while when I compile this thing, it's 55x slower. Oh God. And so I was very much called into deal with that, which is like really super tough because it's like, well, we've made a bunch of decisions already, and it was a big mess. But part of my condition of that was like, I'm going to do this, but then I really need to be given time. I need 6 months to focus on DTrace. And so I've kind of been talking about this enough, and I'm going to kind of go into like this one last firefight, this one last crisis. But in exchange for that, I need 6 months of focus on DTrace. And I wanted Mike and me to be able to focus on nothing but DTrace for 6 months. And
I have this plan for a fire engine.
That's right.
For next firefight.
Yeah, exactly. I want to build a fire engine. I would like to. Well, and I think and Matt Aaron's in the chat is pointing out that yes, the TLB misses. If they missed in what's called the TSB, they would trap into the operating system. Yeah, there's no hardware page table walk, and it was a big mess. It was really, really bad. And I mean, this is like this is part of the reason why Spark was losing the plot to x86. But so I finally got I wanted to get this thing called TrapStat integrated into the system, which allowed us actually kind of on point. TrapStat allowed us to actually, it would instrument the trap table so we could actually say how much time we were spending in the TLB mishandler. And what we discovered is, Matt, I don't know if you remember like the lint pass 2, we learned that lint pass 2, which took forever when you're running on the kernel, was basically spending 60% of its time, which basically meant all of its time, filling the TLB. Because the resonance set was just larger than the reach of the TLB, and we were just and it's basically random, and we were just absolutely thrashing on Lint Pass 2, which was definitely eye-opening in terms of how brutal that could be. But once TrapStat integrated, then I was like, okay, I can go focus on DTrace, which happened sometime in the fall of 2001. I want to say in November of 2001 is when we really got to start focusing on it. And got to focus exclusively on it.
And Solaris 10 had just shipped, Solaris 9 had just shipped.
Yeah.
And I don't know if this is too far, but I felt like Solaris 9 was kind of the completeness of the SVR5, like, or the Solaris 2.0 multi-threaded, multi-core, multi-processor vision. That is to say, I think that's a good way all of the loose ends were sort of tied off. Everything sort of made sense. There were no awful, like, obvious glaring omissions or places where two things didn't intersect appropriately. And that's, I would also say that's why it wasn't just DTrace that got started then. It was ZFS. We got Matt Aarons here in the chat, and Zones, and some other projects that SMF. All were building SMF. There you go, and building on that foundation, which was now, not as rickety as it had been.
That's right. Yeah. I mean, I think everyone felt like I can go off, and it wasn't really planned for everyone to do this at the same time, but in hindsight, it did kind of happen for the same. There was a shared reason underneath all of them, which was, okay, this system works well enough, and the abstractions now work, and now maybe we can think about new abstractions. And yeah, that is Matt and Jeff on CFS, Nay Pacific. That's Fire Engine, that is FMA, that is SMF, and that is DTrace. And DTrace, I think, was probably the first one, because it had been a chip on my shoulder for probably, I think I want to say that DTrace was kind of the first one in the chute. I mean, Matt, maybe Pacific was starting, I guess Pacific was starting at basically the same time. But
and so did you get to put your head down, and actually the organization didn't bug you too much for 6 months?
That's right. It did, definitely. And in hindsight, like, either the organization did a good job of not bothering me, or I did a very good job of ignoring the organization. I'm not actually sure which. But definitely it really did focus during that period of time. I actually think that, this is also when, as I've kind of been thinking back on that period of time, this is the first time that I was really working from home, I think. And that we had kind of all started to work from home, and because I'd not been working from home through 96, 97, 98, 99. It was really only in 2000, 2001 they started working from home. And that really did afford like new levels of focus. I think that people forget that if you really need to go, all this kind of return to the office nonsense, people do forget that, like, boy, when you are working, when you know what you need to go solve, being able to really put your head down and have zero distraction by working from home is really powerful. And I guess it was like a sweet spot, right? Because it's like working from home before like Slack and TMs and text messages. And like, yeah, I don't know. If you want my attention, email me. But I don't know. I read my email like once a day, I guess, at this point.
Right.
And I'm just like,
call my home phone or whatever.
Call my home phone. Yeah, seriously.
Right.
I'm just like super heads down. And it was a beautiful time, because I look at how much, we were able to actually do in a relatively short period of time. So we had started this idea of the kernel technical discussion. And I just remember having this really big milestone around presenting the work that we had done to the whole kernel group. And my view on that was, like, when we did that, this was kind of the referendum on DTrace, and we had to be far enough along to show that it merited additional investment, that I'd kind of won myself the opportunity to work on this for some period of time, but not an indefinite period of time. And I really need to show very tangible wins. And one of the things that was important to me is the ability to actually debug the system and be able to actually get some real bugs and show that we could. And I think that, part of, the kind of the genesis of DTrace wanting to show itself by debugging actual bugs on the actual system, I think was really important. I don't know what your kind of take is on this, but I think that we,
absolutely. I mean, both for credibility, but also to know that you were on the right path and to know what to build. And that was thematic in almost everything we added to DTrace.
Almost everything in fact, everything we added to DTrace was because we needed it. And we needed it, and from a very early period of time. So the first thing that kind of got working was this ability to instrument the functions in the kernel, to instrument with what we call FBT, function boundary tracing, a term that I invented because I couldn't find a term for it. I'm like, what is the term for this? So I'm sorry if FBT is a stinker. I'm sorry.
It's amazing how much that is. People have latched onto that.
They have. Yeah.
Maybe I shouldn't actually you on that one, but that turned out to be a good term, or at least nobody could think of a better one.
No one could think of a better one, really. I think that's actually much more accurate. And I got FBT working, and I knew that we wanted. I think the other thing that was actually really helpful is that all of this. One of the things I definitely wanted to do was replace Lockstat as a DTrace provider. So, in other words, I wanted to separate out the way we instrumented the system from the framework that consumed that instrumentation. And I think that was a really important idea. I think that idea was more important than I realized, actually. Because I think other frameworks hadn't done that. Other frameworks had tied together the way I instrument the system from the thing that actually processes the data, and in a way that was really hard to kind of unglue. And it was very important to have a very crisp boundary, what we call the provider boundary there.
Yeah, other important principle that you nailed in that first prototype or in that first presentation was the ability to run it in production, meaning the system was going full tilt, fully optimized, no weird flags or extra code generated, and then dropping into an instrumented system where the penalty was proportional to the question being asked. And that I know that we've probably said that 10,000 times in 10,000 presentations, but didn't feel obvious at the time, and other tracers at the time certainly weren't doing that.
It definitely didn't have that approach. Yeah, that was a very important constraint when we actually set out, is that this has to be available on production systems. And then that was a constraint, and that was guided from the work we had done with customers, the work we had done on these benchmarking systems. And then I think it also must be said, the work that we had done, one of the things that was really important that we had done, and a decision that definitely predated me and due to Roger Faulkner, the late Roger Faulkner and others, was the fact that we were running the operating system ourselves in Building 17. So we had an NFS server that had the whole building hanging off of Jurassic. And this ended up inspiring other groups inside of Sun did similar things, and we ended up with like prototype hardware. We ended up using this again and again and again. We've used it here at Oxide, and boy, running yourself on yourself is both very empowering and very eye-opening in terms of the constraints of the problem. You become your own customer, and we had to have, because we definitely had issues with Jurassic, and we needed to be able to debug Jurassic, and we couldn't afford to put a debug kernel on there, or a different kernel, or a kernel that actually had this kind of instrumentation enabled. We couldn't take a reboot to go actually debug a problem. We needed to debug it in situ. It had to be available in production. That meant it had to be absolutely safe. So that was definitely a constraint from the get-go. It's like, we have to be safe. And as a result, when we instrument things, and the kind of the contract that a provider has with DTrace itself is that I'm going to instrument the system in a way that is safe, the way that we will not be able to actually roll the system. So it's not going to instrument the system in a way that it doesn't understand or can't reason about. And DTrace will always err on the side of like, sorry, I can't instrument this because I actually don't have confidence about the context that this thing is in. But we do have, because we could figure out every function, entry, and return in the system, and we had a way of instrumenting that pretty cheaply in Spark without a trap, actually, by using an unconditional branch. I was able to get something working pretty quickly with FPT. And I just remember running it on my desktop and being able to see all of the things that were going on in what was the HME, was the Happy Meal Ethernet, which is it has its own story. We need Tom Lyon here to tell the Happy Meal Ethernet story, but it was the NIC that we had at the time, and being able to see everything that was going on in the driver as it was happening, being able to do that totally safely, Control C it, and have the system restored, and being able to do all that on my own desktop. That was like an early moment of like, this thing actually has legs. This is important, and we're going to be able to do things with this that we couldn't do with any other system.
That must have been an incredible moment. I mean, just to have been thinking about this problem for 5, 6, 7 years, and then I don't know, I still get a kick out of seeing like what is going on my desktop right now, and to see that for the first time, like, must have been pretty wild.
It was wild, yeah, and I think it was wild, and it was also like, okay, it was. I mean, vindicating is almost the wrong word. It was energizing, because it was like, okay, we've got a lot of work to go do, but it was one of these things that you when you're engineering something big, you get these, like, the omens become really important. You know what I mean? It's like, it's the seabirds showing that you're close to land, or the dolphins, to go to a nautical metaphor. I mean, those omens are really important. Like, you're on the right track. This is. And you really, especially when you're early in something big, you need to take those things really seriously, because they can be really inspiring, and you need that energy to get through all of the things you need to go do to get this thing done. So yeah, that was great. And I just remember being like, wow, okay, there's a lot we need to go do, but there's a lot we can go do with this. And
so you guys gave that presentation, and as I recall, I mean, it brought down the house. Like, people went bananas for both what you were showing and the vision that you were painting.
Yeah, and I just dropped the deck in the chat for that, which actually was funny. I don't know if you looked at that deck since we basically presented. I don't know if you got
back. Yeah. And I are you going to talk about like the Sun IT naming convention? Is that where you're going? Because I was on slide 1 of that deck, and I was like, oh, they dropped the joke, and then I went to slide 2. It's like, oh, there it is. I remember that. Right. At the time, IT Ops was determined that everyone should conform to this first initial, last initial badge ID as their identifier, and we were all going to get tattoos or something. Yeah,
right, as your username, and you were no longer. And this is one of these interesting cultural things where, like, McNeely was kind of listening to the wrong person on this one, and didn't really understand the issue. And then
he was going to be SM3, so what did he care?
Yeah, exactly. I don't know. Why is everyone so upset? Well, do you remember him like being like, okay, I guess it's like really important that everyone has their call sign or whatever. I'm like, you named your child Maverick after Top Gun, dude. Like, you were on the thinnest conceivable ice here. Okay, like, let's rename your kid. I mean, let's start. Yeah, okay, let's get rid of everyone's call sign, pal. But to his credit, so I think this was right when this was being kind of handed down, and to his credit, they realized that this was a bad idea, and they actually needed to go. And so this was rescinded shortly thereafter, and we were allowed to keep our identifiers. I think they realized that, like, these usernames are like, all right, these engineers take their usernames really seriously. Don't touch their usernames; they freak out. But so yeah, that's in this deck. But so I recall it going on for a long time. It was I think it's the first one that we videoed. I've got the video somewhere. I don't know where. Right now I need to find
VHS. I just want to point out, like, even if you found it, like, what would you do with it?
I actually think we had it transferred to we had it transferred to DVD.
All right.
So it does exist on DVD, and I should make some effort to find it because it's kind of, I mean, it would be, this is like for people think I'm looking now.
Even then, like the DVD player, I don't know, but I mean, fine, good, that's better.
Yeah, I know it is better, but like, where does one find a DVD player? But and yeah, I mean, it was a lot of, I mean, Adam, so it's kind of interesting because like you were effectively in the audience. You had just
100% in the audience. I had nothing to do with DTrace at that point. I was cheering it on, but like I hadn't used it. I hadn't worked on it.
And so I think I don't think people realized how kind of far along we were down. I mean, I do love the fact that we were, and actually I was kind of surprised when they're like, man, we had done a lot in not very much time. And in particular, there were, I mean, we spent a little bit too much time on our own implementation because that's what we were right in the weeds of. But, we had done some actually important things like pretty early. And, we talk about like the safety in there and using the type system and, being able to, aggregations are there and predicates are there. And then also like anonymous tracing. I kind of forgot that we'd done that early. But anonymous tracing is one of these things I think to this day, most people don't appreciate because like, why would you? Who cares? And anonymous tracing is the ability to instrument during boot. And this is one of these things that, most people don't care about because most people don't care. I don't know, the system boots. Like, I don't care about how it performs or what. But for us, it was really important to know like what's happening when the system boots. And it was brutal to instrument the system while it boots. And it was always by hand. And so the ability to have DTrace be able to instrument the system while it booted and then be able to go get that data was really important. And I think in this deck, I even refer to a bug that we found of like, we found obviously lots and lots and lots of issues by shining a bright light on it. We're able to, shave whatever it was, 8 seconds off of the boot time on some ridiculously slow Spark.
Well, and then as you alluded to, we were about to kick off a project that reimagined how boot happened. So it turned out to be incredibly useful for examining that.
Totally. Where you would have these things where it's like, actually, you could do a big elaborate project. Let's actually go gather some data on the system. Like, oh, look at this. We can actually go fix this like 3-line bug. And actually, turns out there's as much performance there as there is in your total rewrite. And I feel like that happened quite a bit. And so there's a lot that's in here. And then, the one thing about this presentation, I don't think it does a terrific job of delineating the things we had done versus the things that we were kind of envisioning to do.
Using the optative voice. Yeah.
Using the optative voice. Exactly. So there are some things here that were definitely still in the future. Some things we never did at all, like the basic block tracing. But this nonetheless was like and I think that it was, I think other folks saw that like, okay, wow, this is good. This is important. And the purpose of that kernel technical discussion was really to get folks excited about the work so we could keep doing it. I mean, that's ultimately, and this is not from like a budget perspective, but really more from a cultural perspective of like, hey, this is, we think this is important. What does everyone else think? And the reaction was really positive, which was great. And then Adam, your reaction in particular was really, really positive. And you were in particular thinking about like, hey, I've been thinking about like how we would go instrument applications. And that was great. But before that happened, so that was in March, we presented that. This is in 2002. And I was going heli-skiing in April of 2002. And how much did I confide in you, Adam, my fear of death from that? Did I?
Zero.
Yeah. So I'd be curious if like Matt, if you remember this, or if anyone else who was there at the time remembers this. And maybe I was just like keeping this. So I've been an avid skier my whole life. I'm an aggressive skier. I love to ski. And would, not really, it would be unlike me to get really, nervous about skiing. And I had this kind of truly once in a lifetime opportunity, because I've done it exactly once, to go heli skiing in Canada, and with a reservation. It was one of these things. We made this reservation in 1999 when it was like the height of the .com boom. It is now 2002. And it's kind of like the depth of the bust, and definitely economically it made a lot less sense.
You're like, why not? I've got the money. Right. Sunstock can only go in one direction.
Sunstock, and as it turns out, Sunstock can only go in one direction. That part was true. I got the direction wrong. So yeah, it made no economic sense by the time we were actually doing it. So I kind of had the economic apprehension of this does not make sense economically. And I'm kind of on brand. I'm beginning to kind of do my research on this, only a week before we're going or something like this. And I'm beginning to realize this is the early days of the internet. Information's not totally available, but I'm beginning to realize this is more dangerous than I realized. And in particular, the avalanche risk is really pretty real here. And, we were going with a very, the absolute best of the best outfit, Canadian Mountain Holiday outfit. But what I discovered is that this outfit had this mass casualty event a couple years prior, and where something like 11 people had died. And
oh my goodness.
Right. And of course, the kind of person who organized this trip is it's fine, it's totally safe. I'm like, are you aware of this incident that happened, a couple of years ago where they lost an entire party, basically? He's like, I was not aware of that. I'm like, yeah, you may want to look into this incident, because they had their most senior guide out there. I mean, it was just one of these things that highlights, when you are in the high country in a skiing terrain that has not been skied, avalanche risk, you can know a lot about an avalanche and still get caught in an avalanche. So I'm like, I'm going to die in an avalanche, and I am going to die in an avalanche, and DTrace is going to be unfinished, because I was working with Mike on this, but Mike, to his credit, Mike was not just working on DTrace. Mike was also working on FMA, the fault management architecture, was also working on SMF, the service management facility. So he's kind of working on more or less three things at the same time. And yeah, someone's asking in the chat, is this before airbags and rescue beacons? It is 100% before airbags. And in fact, I ended up skiing in this thing called the Avalung, which at the time I'm like, I'm going to mitigate my risk here. And the Avalung allowed you to, the idea of the Avalung is that when you die in an avalanche, when you die in an avalanche, you die of asphyxiation, because you create this ice layer right around your mouth. And if you could avoid creating that ice layer, you'd be able to breathe through the pack and the snowpack. And the way to do that is to breathe in air through the pack and then exhale through your back. So the Avalung would be this thing that you would bite down on, and it would allow you to, when you breathed in, it was a valve that sat on your chest. When you breathe in, you'd breathe in through this giant, this kind of membrane on your chest. And you breathe out, it would go out your back. And I can tell you that I think these things were found to not really work that well, because in an actual avalanche, this thing would get knocked out of your mouth and you wouldn't be able to get it. So as it turns out, it wouldn't have done anything for me. I can tell you that socially, it definitely had a cost, because
did you look a little bit like Bane?
Okay, so one, you look different. Also, it's a little bit awkward when you are taking a safety precaution that no one else in your party is taking. You know what I mean? Where everyone's like, "What's that thing?" I was like, "Well, I don't want to die." But okay, but you whatever, you'll be fine. I don't know. I mean, it's you know what I mean? It was definitely a little awkward, made for some awkward conversation. But
and this did not dispel your fear of death, despite breathing out your back.
No, this is not. No, I was just I think that this is a risky activity, and I think I might die. And if I die, because Mike has all these other priorities, DTrace won't be finished. And I remember actually sitting in our apartment, because we also lived together. I remember sitting in our apartment being having this heart to heart with him. I'm like, I think that if I die, you've got these other priorities. You're not going to get this thing done.
And right. But what about your stereo?
No, totally. I just the answer I got out of him was just this is not. I don't know, man. I'm coming in with apprehensions, and you're not talking me out of them. So I had this idea that I unfortunately do not have a photo of. I wrote my last will and testament on the whiteboard at Sun. So I'm going heli skiing, and in case I die, here are the 6 things that need to be done to DTrace. And you do you remember this, Adam?
No.
So, and
The
I kind of
really,
felt like,
really macabre version of Kanban or whatever it is. I feel like
well, I also,
the death post-it notes or whatever.
yeah, well, I felt like if I do die, I mean, God forbid, but this will now become like sacred. And I'm actually, this is just to tell you like how far around the bend I was. I'm like, it will be erased by like the janitorial staff will accidentally erase it. So I like had like save written all over it. So they couldn't actually erase it. And then wrote down my last will and testament, thinking like people will be like, no, we must honor his memory by implementing these. I know also you just wonder like, would that have actually happened, or would they have been like, I'm not implementing that. That sounds terrible. I'm not doing that. I don't care the guy died. Yeah, like he's fine. Like I'm sad about his death. Okay, like
it's like what am I gonna be haunted by the ghost of Brian for not like I don't know implementing tracing the way he wanted?
Speculative tracing? Like really?
Right.
Like, who actually needs this?
Nah, like who needs this thing, right?
It's very esoteric. Yeah, I had my last one testament, but apparently like didn't really. I mean, I guess you don't remember it, so I don't know. I guess it wasn't that effective.
Man, the number of times you'd go into your office and write some manifesto or another. No, I'm just kidding.
If I kept track of every last will and testament you wrote on your whiteboard, pal, I just like. I think there's one sitting in the Oxide office right now. It's like you.
Last for now, right? I mean,
that's right.
So I think that it was, and then after that, Adam, that you and I kept talking, and in particular, because you were working on something in the fault management architecture, I just remember like us sharing like a shuttle ride or something. You're kind of like, I'm working on this, and all I can think about is DTrace. Like that's actually what I want to go work on. And I think this is another one of these like interesting object lessons where you really should work on the things you want to work on. And if you have something that like I can't stop thinking about this, you should go work on that thing.
Yeah.
Whatever that is, even if it doesn't make sense.
Yeah. And I was working on the fault management architecture, which like in theory I was interested in, but just in practice, I could not get fired up for a lot of the mechanics of what we were building. And in the meantime, the summer before I had interned at Sun working on this thing that we were calling libdis, which was about structured disassembly, focused on Spark at the time, but trying to understand kind of a baby Ghidra of understanding how these programs were operating. And it just got me really strongly connected with this, with, machine code and assembly. And in particular, I started thinking about what userland tracing would look like and about, this split program counter, next program counter, and could we replace a particular instruction with a trap? The trick that we were using in the kernel of branching to a new location wasn't going to work in userland, but could we use a 32-bit trap instruction, get into the kernel, kind of move that instruction somewhere else, and resume in userland? I've been thinking about a lot of aspects of that, and true to what you're saying, whether it was on the shuttle or wandering by your office, kind of pitching you this thing, you're like, yeah, why don't you do that? I don't know. That sounds like way more interesting than what you're working on with fault management. Yeah,
let's go do that. And then you, as I recall, like Mike was out of town when that happened. So I'm like, quick, while he's out of town, we're gonna moving from one of his products to a different one of his products. It's fine. They'll be fine.
Yeah.
But that was really important. So many different dimensions. One, obviously you brought like this particular an aspect of the problem that ended up being extremely important, user level tracing, but also just like it just brought so much energy to have. It's really what we needed, honestly, is we needed a third person. And sorry, I had survived, as it turns out. TLDR. I survived telescaling. And it was really,
the first thing I worked on was what we've been talking about this, but you and Mike had realized that understanding where we were in user space turned out to be really important. So the first thing I worked on was UStack. And I swear I was not slow walking into DTrace fish, but that's when you and I independently came up with this maybe clever way of pulling out registers through register windows, which we've talked about in, I think, every episode. So I won't go into the details.
I feel we have, but yet still somehow not enough. Yeah.
Yeah. But that was the first thing I did.
Was USAC interesting? Okay. Yeah.
Yeah. Because and that was a totally new lens, because we thought, we were looking at all of this kernel stuff. And by then I think we even had a syscall provider, but then to tie that into where you were in user space, that was another like crazy moment of insight. Just a new lens onto all of these problems.
A huge new lens, very important. And then so I was trying to remember the origin of the name Mr. Sparkle. When does Mr. Sparkle become?
Yeah, so not surprisingly, we would communicate by and large through Simpsons metaphor.
Something
and that's right. And the PIT provider had kind of two pieces of it. One was the raw instrumentation of when an instruction was supposed to execute, how we arranged for it to appear as though it had after firing the probe. But the other part was identifying the location of probes. And we've been talking about this provider as Mr. Fast Trap for a long time. I'm not 100% sure why. But then what we did in userland is sort of disassembled all the functions to understand, where function entry and return, and then where the discrete instructions were. Something that we sort of got differently through the kernel linker for FBT, but for userland we need to kind of pick our way through because we didn't necessarily have the same preamble and suffix as we did for all these functions in the kernel. So we started calling that thing Mr. Sparkle. And actually, to this day, Brian, if you turn on debugging for DTrace, it will vomit out messages prefixed with Mr. Sparkle as Mr.
Sparkle lives.
As it stumbles. In particular, it would get really freaked out if it found what it thought was a jump table. Jump table is, right. What would happen is you would have data effectively sitting within the range of a function's symbol. The data was used to inform where sort of a densely patched switch statement would redirect. And without this identification, Mr. Fast Trap and /DTrace would identify a bunch of data as though it were instructions. And that didn't go so well. When you started replacing data with trap instructions, then it meant you would fly off into outer space with very little, to help you figure out how you got there.
And your application would die.
Spectacularly, often like several instructions away, maybe dozens of instructions away from where the actual incident occurred, which made it even trickier to figure out how you got there.
And so, all right, so this thing we started calling Mr. Sparkle after the terrific Simpsons, the fish bulb.
That's right. Mr. Sparkle being the confluence of two Japanese industries whose logo looked exactly like Homer. See notes for complete details.
An episode that we love so much that we implicitly named Fishworks after it.
That's right.
It really is a great episode. Actually, we had a coworker that studied Japanese in at
Joint.
Yeah, Elijah, and I had Elijah watch that episode too, because I just wanted to understand more about the Japanese. Seems so plausible. Yeah, the Japanese is very good. He's like, it's very formal Japanese, but it's very good. This is really interesting. It's great.
Nice.
But so and I remember another big milestone was when you could instrument every instruction in Firefox. Am I remembering that correctly?
Yeah. So that there was a bunch of failed attempts at that, which involved like driving off into a ditch, but things like how you deal with asynchronous signals being delivered while you're in the midst of executing a one of these trace points. So there's lots of corner cases to consider along those lines. But yeah, then we'd go from a Firefox that we downloaded off the shelf, turned on millions of trace points. The thing would slow down a ton, but it was still usable, and that it was pretty wild.
Yeah,
was it Firefox or was it Netscape at the time?
It was Firefox. I am pretty sure it was. No, excuse me. It was Firebird. Right? I think this is before. Would that make sense, Josh?
That was definitely a thing before Firefox.
Yeah. So actually, if you look at the DTrace,
it was Mozilla, right? It was Mozilla. Wasn't it called Mozilla at the time?
I think it was Firebird. In the DTrace documentation, there's lots of examples. I actually kind of deliberately did this when we were doing DTrace examples. I'm like, I want to capture like little time capsules in the DTrace documentation. So I did this over and over and over again. This is like my little Easter eggs,
Oh my
or
goodness.
little where I would deliberately like capture the date or capture the applications that were running. Because I'm like, I want to capture like the applications of the day. And I definitely remember like, so there's a lot of Firebird in there. Now that may have been Mozilla before it was Firebird, but it was on Spark, importantly, because this is not on x86. I remember, Adam, when you were talking about Mr. Sparkle. By the way, if you go into the source base, it is great. Like you search for Mr. Sparkle from like 6 different points that still have Mr. Sparkle in there. I hope that future civilizations choke on that one, AGI. Like, hey, go make sense of that one. You're so smart, you Mr. AGI, rewriting us all. Like, what does that mean, Mr. Sparkle? Of course, it's listening to this episode right now, so I was getting away. I was stupid. I really should have thought about my service to the Lycon before I did that. But I remember thinking vividly, like, this will never work on x86. Do you remember that? Like, we were like, okay, this is going to work on Spark, but on x86, we're just like a hose. We're just going to have to do something completely different.
Yeah, and definitely.
When we integrated DTrace, we did not have we did not have PID provider support for x86, I think, right?
That's right. But did you have FBT support for x86 at the time? Because FBT, like, I don't think you could take the branch. You had to take a trap there as well.
I did take a trap. I couldn't do the branch, and I did that via. I wanted to avoid the fact that with the trap instructions, 0xCC gets you, like, the debugger gets confused. So to prevent the debugger from being confused, I generated an illegal instruction with a lock prefix.
Oh, that's right. That's right.
Questionable decision. So yeah, and I can't remember if we had that when we integrated or not. I think we had FBT on x86. Maybe. To
be clear, x86 supported sort of, but like clearly a second-class citizen at the time, which is insane. And perpetually like being announced that it was being killed, but then we would rally to unkill it. So it was in limbo for a very long time.
Well, and I think the great darkness for x86 is, I believe, like January of 2002 to October 2002 is that I believe is the era in which, because remember, it was killed. Do you remember this?
Yeah. We went to like an all hands for the engineering organization, and they're like, x86 Solaris is dead. And then we all went back to building 17 and talked about how we'd keep it alive.
That's right. And we're like, we are going to keep it alive because this is so obviously the wrong decision. And we will perish if it was so obvious. I mean, it was just, it was a very bad decision. It was a very bad decision. And the person who made that decision, you know who you are, and we know who you are. So we'll just leave it at that. But it was a very bad decision that was ultimately revisited, importantly, and it was resurrected. But so the operating system had only been resurrected. I think it was, I want to say October of 2002 that it had been resurrected. So I think maybe had FBT for x86, but definitely not the PID provider when we actually integrated. But then I think you did the PID provider. I think that was like the next thing that we did was the
That's right. So for a long time, I had a workspace, like a branch called Fast Trap -X. Do you remember this, Brian? And like everybody's laptop was running Fast Trap -X for a while.
Oh, Fast Trap -X. I love that workspace.
So it was like
a workspace being the Git branch of its day.
That's right.
And yeah, I'd forgotten. Right, Fast Trap -X. Oh, so another thing that I thought was interesting was that I know Matt is here. I'm not sure if he wants to hop on stage to speak, but one of the things that was really neat was before we had integrated, projects had decided that DTrace was so important to them that they would actually be a child of the DTrace gate. So they were, and you can again view this in teamware parlance, but we had effectively created a fork of the operating system that we were staying in sync with. And so people had decided that instead of syncing up with the operating system, they were going to actually sync up with the DTrace gate because we were synced up with the operating system. And then they would get kind of DTrace for free. And I know that SMF did that. I think CFS did that as well. But a couple of folks.
I'm pretty sure Zones did that too. Anyway, there were a bunch of folks backed up, and we really needed to stick that landing before you died heliskiing.
We needed to stick the landing, and And we had a very exciting integration that we talked about recently. So that was don't need to belabor that one. That was a very exciting day. And ultimately landed. And when is AA debug, Adam? That must have been.
That was before. That was earlier, I think. Right?
Was that earlier in 2003? Because I had kind of. You're right. I think it must have been. So
That's right.
You and I had gone to Ghent. That was in. Oh, that was right afterwards. That was right after we integrated. Man, no wonder we felt like we were up against. We had a narrow window. That was September 8th, 9th, and 10th. Of course it was.
Oh, that's right. I forgot. Right. That's right.
Of course it was. We should have definitely remembered that. And so we should also acknowledge that today is 9/11.
It is.
And of course, because we were in Belgium, and this is only on the second anniversary of 9/11. And the first anniversary, for those of you kind of like were not alive or were not aware, 9/11 was awful, obviously. But it was like rip your heart out awful. I remember, and Adam, you had just joined Sun.
I just joined, sort of a newly minted adult, sort of. And
yes.
It was the whole world changed.
It was just devastating. And it was like, and many people have connections to New York. Sun lost an employee on one of the planes. I mean, it was just like devastating. And then I remember the next year being so angry that was not a holiday, that we worked on September 11th, 2002. I remember being like, this should not be a work day. No one could work. It was just like, that should have been a national holiday. It should have been a national day of mourning. It was really awful. But by the time we hit like September 11th, 2003, it was beginning to like the scar tissue is beginning to form. It wasn't like it didn't have that kind of recency to it. And you and I are in a debug, and like everyone is kind of feeling a little bit calmer. And then Osama bin Laden is on September 10th. You and I are both traveling on September 11th.
That's right. Flying. I think you were like flying to back to DC or something.
I'm flying from Brussels to DC. I'm flying from the head of the EU to the head of America on September 11th, 2003.
Right.
And as it turns out, that was a pretty empty flight. I had booked that because it was like really easy to get a ticket without realizing that, like, wow, this is
like
great.
So cheap. I'm saving the company so much money.
I'm saving the company so much money. You're like, oh, I'm like thinking like I'm going back on Thursday. And then I'm like, no, I'm going back on 9/11. I'm such an idiot. And then I was feeling somewhat apprehensive. And then on September 10th, if I recall correctly, you and I are in Belgium together, and which was for a lot of fun for a bunch of different reasons. We'll get to kind of the DTrace consequences of that trip in a second. But Osama bin Laden is like, I'm going to do something even more terrible on this 9/11. Like, I'm going to do something. I'm really going to blow your brains on this. Like, this is going to be really amazing on this 9/11. And I remember being like, shit. And I remember, Adam, do you remember your counter argument to this?
Yeah, I remember thinking that would be bad marketing. Thinking if someone says 9/11, it already means a thing. So Then it just gets confusing.
It's like, no, this is the one day you wouldn't do anything on. You'd be like, oh, that 9/11 was the most spectacular of all. Like, which 9/11 are you talking about? First 9/11, second 9/11? It's like, it's going to be a marketing mess. And this is going to be
like Coke Zero? Is that?
It's going to be Coke Zero, Coke Classic. This one dies in committee at Al Qaeda. And I remember feeling like total solace at that. I'm like, you're right. This. But the kind of the DTrace ramifications of that. By the way, I was feeling a lot less confident when I was actually on the plane, which is like very clear that this plane is like basically 3/4 empty, and everyone else seems to be like an air marshal. So I'm not sure if I picked the right day to travel or not. But the DTrace ramifications of that, I remember like we have to write a DTrace paper. Do you remember us talking about that?
Yeah. Right after hanging with these academics, yeah.
Yeah, and I think we felt like it is very, very important that we write a DTrace paper, and that became a top priority. I mean, there was technical work to do after the integration, but writing the paper that became the Usenix paper that we would present the next year. I'm not sure when that must have been submitted in like November or something like that of that year in order to be I feel very fortunate. I mean, it was like the acceptance rate was getting extremely low for Usenix, ATC, the Annual Technical Conference. But that paper ended up being really important, and I'm really glad we did that. I'm glad that we forced ourselves to do that. And
Yeah.
another kind of big lesson of DTrace is it is really worth forcing yourself to write this stuff down. I don't think I don't think an academic conference is the right thing for most practitioner authored stuff. But I think, whether it's a blog entry or an ACMQ article or getting that kind of written vessel is really, really important to describe work.
Totally agree.
So then I do kind of want to move forward in time here. So DTrace becomes, we believe it's a big deal, but that's in part because we're using it. Other people start using it. It's pretty clear that it was a lot of fun to go demo, which was great. The blog, when do blogs.sun.com, when does that happen? Because I feel like that happens like almost around the same time, like 2004.
Maybe right around that time, because I'm not sure when we open sourced it, but I remember DTrace being the first thing. I remember some of our early blog posts talking about. No, it was maybe even. Yeah, it was 2004 because we were talking about the launch of Solaris 10, open sourcing DTrace.
That's right.
It was right around that time. You're right.
Yeah, and so I think we did and a huge credit to Tim Bray encouraging Sun engineers to blog. And so we started blogging in 2004, and we were really be able to be much more transparent about what we were doing, which was really important, I think, for us to be able to like really talk about DTrace. And I feel like DTrace was kind of like born on social media in that regard, albeit primordially, because people were not relying on kind of official Sun documentation for this. They were getting this kind of from us and us talking about what we were doing. And the blogs were really important for us, I think, for DTrace.
No, that's right. And both getting it out there and then hearing people's use of it, I think that was a really important vessel.
It was really important. And then I do love going, although it's a bit hard admittedly on DTrace.org, which has got a down rev WordPress installation that desperately needs some attention.
We are like WordPress at 20. Yes.
What is WordPress at 20?
Why would you say that out loud? Oh my God.
I know, it's so stupid. I know. Please. But the comments were really good. So, this is like, we're so old, Adam, that we remember when comments and blogs were productive.
Yeah, you'd like respond to people on blogs and have like a whole discussion without any Nazis.
It was amazing. And like the biggest problem was like people who were just trying to sell you things as opposed to like actually. So those were definitely halcyon days, but that ended up being really important. And then that's like we started to get like real community around it. Then, as you say, we open sourced it in January of 2005, and that was the DTrace was the first thing out of the chute, and we wanted, and in part because DTrace was clean from an IP perspective. DTrace had been wholly developed by Sun. We were not waiting for anybody to relicense anything, so we needed something that we could open source to show that we were serious about it. And because we wanted,
and in particular, show that we weren't holding back the crown jewels. I think that was one of the things that, as we started talking about opening up Solaris, that people were convinced that we would give away, the stuff that the 20-year-old crap, but not like the newest hotness. And so we started with what we thought was some new hotness,
which was great. It was kind of an honor to be in that position, and was really important to us to open source it. That's when we turned into the DTrace fish, and it's shared ancestry, the mirrored ancestry. But it was really important for us to get that out there and to get that open. And I remember at the time being like, another part of the reason I want to get this open is I want this technology to survive the company that it's in. And which turned out to be, a bit too on the nose, but it was really important to me that like this become a contribution writ large. And that in particular, I remember thinking like, I do not want to, the thing I desperately wanted to avoid was some years later in my career pining for what we had built and not being able to use it. It would just feel so gutting, to not be able to use this stuff, because DTrace was so important to our kind of everyday use. And Jason in the chat says, still remember the first issue that I used DTrace on. And you remember, Adam, we used to talk about this with people, like you could see the change in disposition between people who would like, yes, I've looked at DTrace and it seems neat, versus like DTrace just pulled me out of the fire. And
Okay, you know what? I love that I still get to see that, and we still get to see that where with our colleagues at Oxide, where we show it, they've seen it, whatever, but then you get that DM, and I'm sure you've gotten lots of them because I have. It's like, hey, no, I actually used it, and holy smokes! Like, how would I have done it without it? How do other people live? It's like, yeah, no, it's great.
it is great. It is really, really, really exciting to be able to do. It's exciting to kind of be with someone when they realize like all of these things are now possible. And
Sure.
yeah, it's been, I mean, honestly, has been one of the things that's just been a singular source of kind of pride for us is that this technology still is able to deliver this kind of delight to people. And like, wow, there's so much I can go do. It's really great. And as you say, this is up until like present day because we've been able to do all sorts of things with it.
So two things I want to touch on. So I don't want to throw out my shoulder, patting myself on the back on this, but we did get this Wall Street Journal award, and the reason I want to bring it up is that we beat out inhalable insulin. We beat out inhalable insulin for the top prize. Turns out inhalable insulin had a bunch of problems, whatever, but it meant for the first time I could both explain it in terms that my folks would understand, where they could say, oh, inhalable insulin, that sounds really fancy, and you beat that. And more importantly, they could brag to their friends. So that's the reason I want to thank the Michael Totti and the Wall Street Journal.
Yeah, totally. Yeah, it was great. It was funny because we had all of a sudden this kind of a spotlight that we didn't imagine that we would be kind of featured in this way. We did beat out inhalable insulin, which really seemed to be the headline for many people. Like many people like, what do you think? Like diabetes isn't important? Like no, we're not denigrating inhalable insulin. Adam, I like that you point out, like for the record, inhalable insulin had many production problems. And
where are you now?
Using inhalable insulin now? That's like you're not in the podcast doing inhalable insulin at 20, are you? No, I'm not listening to that one. Go find that podcast. Yeah, it's a dead letter, inhalable insulin. Very important.
Definitely like one step up the ladder, at least from like a local boy makes good, like local town newspaper photo that your mother puts on the fridge or whatever.
Exactly.
It was, and huge kudos actually to the folks at Sun. I think Claire Travano in particular had really reached out. It's a nominating process you got to go through for that, and they had done all that stuff, which was great, and really appreciate that. And because it was nice to get that kind of attention on the technology for sure. Because that was in 2006. When was that?
2006, yeah,
which is great.
Yeah. And the other one was that I want to talk about is you mentioned Lockstat at the top about being one of these kind of early dynamic instrumentation, but kind of statically scoped tools, and that you converted then to operate in DTrace. We had the same idea in userland. We thought, what's good for kernel locks would be great for userland locks, which are a source of even crazier, weirder pathologies. And I don't remember this, but I had built this implementation of Lockstat, userland Lockstat, that was terrible. It was just awful with these like implicit symbols strewn all over the place. And we looked at it and we said, nah, like we can't ship this. But that was the birth of USDT, of userland statically defined tracing, where
I didn't realize that's kind of where that was coming from the
Lockstat. Huh. Yeah, so that was the first USDT provider, was the Plockstat provider built into libc as a way of sort of decorating these locking primitives with the information we need to instrument them. But then totally like caught by surprise, that turned out to be an incredibly powerful tool for dealing with dynamic languages, something that we did not anticipate when thinking of that thing.
Yeah, and so we should also talk about UStack helpers at some point.
Oh yeah. So a bunch of that was done for, with the Java folks, because we were at Sun. That's right. So because we were at Sun, everything was Java. So they sent the Java powers that be over to hang out with us. And we thought, how can we do meaningful instrumentation for Java? So half of that was a USDT provider, the hotspot provider, for examining various aspects of Java execution. But the other one was, as Brian was saying, JStack. So building a bunch of instrumentation into the binary itself, which would help DTrace in the kernel figure out how to assemble a stack trace. And that was pretty wild.
It was absolutely wild, because in particular, the JVM basically downloads a program that allows us to answer the question in situ, which say in a context in which you cannot block, you cannot execute user level code. You're not actually Turing complete, by the way. And we need to know for this symbol, what is the string that it corresponds to? And that was, writing a DTrace helper is, because it is not Turing complete. I mean, that is programming your calculator. It is super weird to go do. And then, do you remember the tracing framework I did for helper providers?
Oh yeah, there's this kernel switch you can turn on for it to emit failures, basically.
Yeah, so you can have some way of debugging these things, because they're just brutal.
Yeah.
And I remember thinking, is this the simplest way? But I think we all kind of came to the conclusion, this is enormously complicated, and yet it is still the simplest way to do this.
You're basically running a program in a virtual machine that's an entirely safe context to examine the process memory, right? I mean, that's I don't know how you could make that simpler and also make it cover all the cases.
And did you put program in air quotes as you were saying it, Josh? To express
I did not. No, I mean, it's a program.
It has no backwards branches, so it is not a program.
but that's why it's safe.
You are executing a series of statements. Yes, and it is why it's safe. And I do think that so one thing that, and I think we talked about this at the top, but one thing that is really important to understand about DTrace is safety, and is at its core. Safety, production systems, and used pragmatically on debugging problems. And everything that we have done comes from that. And there, as a result, because some people have asked, I don't know, what's the difference between this and eBPF, or what's the difference between this and System Tab, or what's the difference between this and whatever. And it's when you can go find all of these surface differences, of which there are many, but there's also just a values difference at the core. And the core of DTrace is allowing you to safely understand what your system is doing. And everything that we do is we're not trying to augment the system. It is not a vector for delivering arbitrary software into your kernel. And it's not designed to be, and it won't be, because that would violate the safety principles of DTrace. And
you can't understand this enough, because that safety built so much content where you could bring this to the most critical customer system and know with confidence there was nothing you were going to do that was going to fuck things up.
Totally.
And this meant that there wasn't nervousness around when you'd use it, where you'd use it, what kinds of problems would be applicable for, what kinds of customer systems. It bred this confidence. Now, it also had associated limitations, but that confidence far outweighed it.
We would deploy instrumentation to thousands of machines at Giant without thinking about it. Really, when you're looking back, it was very little concern given to the potential downside, because there basically wasn't one. It would, even if you would at worst get back unhelpful data or something, but it wouldn't. No customers would be calling up saying you just destroyed 100 of my instances all at once.
And there are, so DTrace is safe by design, and so it's designed to be safe, and we did a bunch of things that are important in the implementation to make it safe. But even as safe as it was in the implementation, and in fact, Adam, it was with the UStack helpers. Do you remember the issue that Jared hit with the UStack helpers? So he was, Jared Jensen, one of the earliest user of DTrace outside of Sun, was just going to town with DTrace. DTrace and Jared were a great fit for one another. And so he was deploying it wherever he could on any kind to be able to get these wins on these kind of financial applications. And in particular, these things are in Java, so he's using JStack a lot. And I'm pretty sure Jared was the one who hit because a big UStack could take a long time to run, hundreds of microseconds pretty easily, even up to a millisecond to run all this, because you're going through a lot of, for every single frame, you're going to ask the question, like, what is this thing? I need a string. And you start doing that for, you're 500 frames deep. And it's like all this, it's pretty easy to add up to like hundreds of microseconds, milliseconds. And it's Spark, it's, 2001 or whatever, and 2003 at this point. And I remember Jared like ran this and the system just became unresponsive. And so like the system was up by some definition.
Technically, right.
And that was a big eye opener of like, wow, we, even as safe as we have designed this thing to be, simply doing no harm to the system is actually not enough. You actually have to keep the system alive. And there's a bunch of liveness criteria, and you can go on some scary vacations because you end up with an enabling that's got a really heavy probe effect. And Patrick, I know you and I have both sent the system on some very scary vacations. But importantly, like DTrace will realize the system is not making forward progress. And DTrace's assumption is if the system is not making forward progress, I DTrace him to blame. So I'm actually going to kill the enabling. And I will let the user know this enabling is dead. And that I think was a very important decision to be able to go do that and to give us the assurance that at worst, you're going to get this kind of black hole moment that you'll actually come back from, which is very, very important.
Like handfuls of seconds, and then things come back.
Yes. Have you hit I assume you
the systemic unresponsiveness?
Systemic unresponsiveness? DTrace aborted error message?
Once or twice.
Yes, I have saved you from death. Or you have been saved from death, actually, because you're like, you've saved me from death. I think I think you said that you were almost causing my death.
Yeah. Well, I mean, you were only you can prevent systemic unresponsiveness, I guess. But yeah.
Yeah, but the JStack highlighted the need for that because you need to be. We just found you're running that out of a profile provider or what have you. It was just very easy to like really burden the system, and it was very important that we had that kind of escape valve to make sure that the system would correct. Because Adam, I think our disposition was rightly we had zero opportunities to screw that up. Like DTrace takes out your system once, you're never going to run it again when it matters.
That's right.
You just do not have a do-over on that one. And I think in that regard, it very much mirrors Matt and Jeff's disposition towards CFS, where it's like, no, the number of opportunities you have for data corruption are actually zero. Like the thing corrupts your data, and you're going to be talking about it in Hacker News comments for the rest of your life. And with DTrace the system did not toss, and with ZFS we did not have corrupt data, and it was very important for both those things to operate from those constraints on out. Everything we do was abiding by those constraints.
Should we talk about the post-Sun DTrace journey?
Yes, I think so, because I do want to. So we did the in 2008. We did the first DTrace.conf. That was not post-Sun, but that was kind of post. We had left the operating system group, and we are now in this group at Fishworks. Yet another reference to the Simpsons episode. And I did love we had a DTrace conference. Which sounds like, why would you have a DTrace? I mean, really? Do you have enough people for a conference here?
Sort of, yeah.
Yeah, sort of.
How many people showed up to the first one?
Like 100?
Yeah, it's same as the second and the third, about 100.
Yeah,
that's pretty
but
good.
It's been about 100 every time.
Yeah.
I'll take that. And
yeah.
Especially because Stephen O'Grady was there. Stephen O'Grady's like, I'll come out for this. I'm like, all right, great. And Stephen was super skeptical. He's like, oh my God, what are these people? And I think Stephen, it would be interesting to know what he said now, but I think he was like, this is by far the most technical conference I've ever been at, where it's like the old kernel level software is viewed as like high level around here. Like these people, and we had like Steve Peters there, and from Apple, who I love Steve, and talking about, in particular, the way, do you remember he was talking about how they'd use DTrace at Apple on...
No, I don't remember this.
Oh my God. Okay. So no, he had like a Q&A, and they were talking about how they had found this really nasty performance problem using DTrace. And, Steve is such a great technologist and so earnest. And it was really good. Those videos are kind of like out there a bit, but they're terrible quality. Have you seen any of those videos, Adam?
No.
They're bad. We did have, but we did play the ping pong variant of our own invention. That nice. Is still that is still a omnipresent theme in our lives. Fish pong. We got burritos. It was a lot of fun. We had everyone. It was great. And we had John Burnell there. John Burnell, who actually died suddenly, unfortunately, only a couple years after that. But John Burnell had done the FreeBSD port. Remember that?
Right.
And I had done so that was a lot of fun. I really enjoyed getting everyone together, and it was there that Steven was like, "Yeah, this is great, but I don't know, man. Like, what do you mean you don't know?" It's like, "Well, it's like, what are you gonna do next year?" Like, I don't know. What do you mean you're gonna do next year? It's like, if you do, like, there's no way. Like, it's not gonna be this good next year. It'll just be a downer next year. Like, you can't recreate this. Like, this is so incredible. You'll never be able to recreate it. I remember being like, can you just like let us have this day? Can we talk
Can we
about
just
this
have a
tomorrow?
moment, please? Right.
Yeah, can we just like enjoy this right now? Like, maybe we could like be a downer tomorrow. Like, today, this seems pretty great. But I really feel like, God, he's really right. And we were like, okay, we need to not do DTrace.conf every year. And in fact, we ended up doing it in Olympiad cadence. So we did DTrace.conf in 2008. And then we did another one in 2012. And that was at the Children's History Museum, I think, in San Francisco. And then another one.
That one?
You were at that
There
one.
you go.
Yeah.
Yeah.
And then we did another one in 2016.
Yep.
And I think
I'm wearing
Adam,
that shirt right now. Yeah.
I am also wearing that shirt right now.
Why not?
I saw in our earlier meetings where I'm like, you know what? I'm also going to wear that shirt today.
There you go.
That was a lot of fun. And I think,
I remember when I joined Oxide, I said, 2020 Olympiad year, we can start to sponsor it. But little did I know.
Oh, did you know? 2020 canceled.
Right.
And then we kind of like, then the pandemic wore on. Adam, I am here to pledge DTrace.com 2024, baby.
That's right. You heard it here first. Unplanned.
Yeah, I think we are going to do a DTrace.conf in 2024. We're going to do it at Oxide, and it's going to be fun. That's what.
There we go. And there will be fish pong. We promise all of these things.
There'll be fish pong. There'll be food. We'll have a T-shirt. It's going to be great.
Yeah.
How many? Oh God. 2024. We've got. Okay. We've
got some time. We got a minute. Yeah. We got like a year.
We got a year. We're going to do it, and it's going to be a lot of fun. And we're going to get the band back together. Because there are a couple of things I want to talk about that are recent innovations. So do you want to talk about, Adam, is this a good segue to get to USDT on Rust? Because I think this is where you get to our modern day.
Absolutely. I mean, I think that it's been great using DTrace for all these years, but then you find yourself wanting it in these places where you don't necessarily have easy access. So one of the things, is it like 2 years ago now that Ben Nacker and I worked on this? Maybe more. But so we built this USDT crate for Rust so that we could have statically defined probes within the programs that we've been building at Oxide, because we're mostly building Rust stuff, and it's been fantastic. And I did, however, and Josh Patrick, I don't know if you guys have seen this. I sent this to Brian earlier. In the earliest days of like Rust ideation, Graydon Hoare has this bug. It says, wouldn't it be great to have DTrace probes built into the language? Of course, that didn't come to be, not natively. But we've got this USDT crate and are using DTrace probes in all of the components that we're building, and it's been incredibly useful.
It has been it's been huge for us, and the ability to add new probes to this thing. It is so, man. You and Ben did such a good job, Adam. It is so easy to add probes to this thing. And
you've been using it a ton in like looking at storage performance, and I don't know, for understanding the system, it's been super useful.
It's been really useful, and I think that
in particular with Rust, because it's the stack, the symbols are mangled, and the deep inlining often, like, you don't end up with frames for you don't end up with frame pointer frames for a lot of the source visible frames. So like being able to put the USDT probes in with unmangled names is very helpful.
That's right.
It is very helpful, and I think that's going to be. I mean, there's a lot of work still to do, and I think a lot of it is around making it. I mean, it is possible. In fact, actually, Adam, we just used this on this really gnarly data corruption problem that we had. That, as it turns out, was due to a bug that we had compounded by a disagreement about what correct microprocessor behavior is. I think it's the most generous way to phrase it. But and really, in order to be able to nail that, use DTrace a lot. It was really fun with Rain Paharia here at Oxide, and we're using DTrace to debug it together. And I think she was like, "Wow, this is amazing! All the stuff you can do." But we really were using your ability to instrument an arbitrary instruction at userland, which we've kind of forgotten about because we so frequently use USDT. And then when we're not using USDT, we're kind of using the function entry and return. It's like, no, you actually can instrument any instruction in a process.
You can even instrument things that aren't instructions if you're not careful.
Now, including the ability to instrument trump tables. But that was actually really clutch for us in that problem because, as Josh said, it's like you do get like really rampant and aggressive inlining. And, this is one of these things where it's like DTrace makes these things possible that are literally impossible. And then, it's like once it's possible, you can make it easier to do. But boy, that delta between impossible and possible is a big one, as it turns out.
Yeah.
I guess another like favorite feature that I feel does not get that was absolutely clutch for us at Joyent. I kind of hope it's never clutch for us at Oxide because it's a little. You know that you're in deep when you need this. Is postmortem tracing, Adam? I'm not sure if how frequently or if at all you need this.
I've definitely used it, but it's been a minute, probably back to the Fishworks days, or maybe some of the work I was doing on ZFS after that. But postmortem tracing is pretty wild. It's like this flight data recorder, this customizable flight data recorder that you dump in and then let your kernel execute until it crashes, and then you pluck it out and you can see the events from that flight data recorder. It's very cool.
Yeah, so this is using Concal and DTrace state and MDB, and it allows you to actually you use the ring buffer policy to actually just constantly roll over your buffer as opposed to kind of pulling them out to userland, and then you can instrument a system. And so in particular, we had this nasty data corruption problem at Joyent. I'm knocking wood right now because I want to show adequate reverence to the gods. Please do not punish me with another one of these. Where this was a pre-existing bug in the operating system where it would effectively steal pages from underneath you, and so it would incorrectly consolidate pages effectively.
OS 1028, as I recall.
OS 1028. Yeah, OS 1028 was our internal. You can retain the ticket numbers for the rest of your life for the firmware revision or the OS revision or whatever it is that caused the misery. But yes, OS 1028, and this was absolutely brutal. So Adam, this is one of these things where it's like, you're panicking because like the in-kernel data is corrupt, and you look at the corrupt data and you're like, this is a customer's Apache log. You're like, okay, time to like.
Where did you get that?
I'll be right back. I'm gonna throw myself into traffic. Like I am actually like, and this time I'm not writing anything on my whiteboard. I'm actually just. I think it's just for the best that I just push myself onto the ice flow. I need to be done. Super scary, and we use that to be able to. And it was just kind of happening randomly, effectively, and being able to just bifurcate the search space by instrumenting the kernel. And then leaving this instrumentation running, and then it is actually great when you have this kind of instrumentation running out there. In our case, the Joyent Public Cloud, when a system would roll on it was good news, not bad news. It's like, all right, we're going to get like more data about this, and ultimately, that is what we absolutely needed that to crack that case, and it was chilling. And so that's one of those features I think, Adam, that's just like not well known and not something you're going to find in any other system. Probably doesn't matter to that many people, probably doesn't matter that frequently, but when you need it, you absolutely need it.
Yeah, no, totally agree.
I kind of put speculative tracing also in that bucket, by the way. I love
for sure.
Tracing. So has anyone ever really used that?
That's become a meme for like the last 15 years, but the feature that Brian wrote so you can record data into a speculative buffer and decide later on whether that was an interesting sequence of events and you want to trace it out, or a boring sequence of events and you want to toss it. So when you're looking at some very low probability kind of pathology, it lets you not have to postmortem or after the fact sift through tons and tons of data, but rather get the concise answer like right away.
And Adam, I'll tell you, I still use speculative tracing for debugging performance outliers, latency outliers. Where you have like, I want to actually like I'm going to instrument the beginning of this operation and the end of this operation. And I'm going to instrument some things that I'm very suspicious of in the middle of the operation that may be inducing these P99s. And then if our latency is longer than this, I want to commit that buffer and see if we're hitting this. And it can be very useful to kind of quickly explore one of these hypotheses.
Yeah.
So yeah, what are some other, Adam, do you have any others?
Well, so, I mean, there's, first I'd say, like, I think we've been talking a bunch about, you and me and Mike and some of the others, but, there's, it's been ported to, we mentioned Mac OS. I've seen a demo in the back of a dark auditorium on the iPhone. It's on the PlayStation Portable. It's on Linux. There's a Windows port. I don't know if you've played with that at all, but I got excited about the Windows port and kicked the tires on that. And then there are tons of people like Josh and Patrick who were on earlier, or Patrick who was on earlier, Josh who was still with us, Robert Mustaki, Dave Pacheco, who have built like tons onto DTrace, extended the capabilities. Patrick has fixed a bunch of critical issues, so it's taken a whole village.
Yeah, it has. The Josh, in particular, you added the JSON action, which I thought was really. Do you want to talk about that a second?
Yeah, we had so we had an early structured logging thing, Bunyan, back in the Node era at Joyous, and we would emit log records that could contain quite a lot of JSON properties, some of them nested, and then we had produced a USDT provider where we would emit all of the log records, even the trace and the debug ones. If the probe was enabled, we would emit those log records as probes. And one of the parameters to the probe was the object that contained all of the structured properties from the log and the message and stuff. And we wanted to be able to pick out in order to do an aggregation in DTrace, you have to have the string or the number or whatever it is like available in the probe context. So you need to be able to pick it apart in the kernel before it eventually makes its way out to user land for post-processing. So I had added a subroutine like in the D language to do that with like a CSS selector style or like miniature JSON XPath sort of thing, where you could name a particular property in a JSON blob string that we'd pulled out of a probe, and it would pick out just that value. And so we could pick apart a bit like a 2 kilobyte JSON object and lift out the 8 characters or something that we were interested in.
Well, and in particular, it means that you can actually put that in a predicate.
Right. Yes, and aggregate on it, and I think I also added at the time there was no like string to number routine because we wanted to be able to pick out. We wanted to be able to take numbers that were really strings and turn them into something that we could like quantize, which was handy as well. I think they both went in together.
Yeah, and someone in the chat is asking about the Oracle port of Linux, which actually is I know it's off-brand here for me to say anything even vaguely positive about Oracle, but this is actually the Oracle port is actually good, Adam. I think.
Yeah, it got better. I don't remember this, but I tested out. I kicked the tires on the first version. I sort of a history of this, but kicked the tires on the first version, and I was tracing a bunch of stuff, and then I couldn't SSH to the box while the tracing was enabled. So, but it is definitely improved over time. But same thing with Apple had some problems early where Apple didn't want you to be able to detrace things like iTunes, because of DRM stuff. So a lot of the ports have had some foibles, but they've gotten ironed out.
I feel like you had a customer early on that did not want their software to be visible to DTrace.
Yes, we did. I did not deal with that well. The first, I dealt with that. I think everyone after the fact can agree that Brian dealt with that situation poorly. I was surprised. It was not Veritas, it was Reuters actually. And if you are a Reuters customer, you may be like, I knew it. Reuters makes financial services software. Reuters is a lot of things. And this is at least back. I'm not sure. I'm sure they've divested themselves of this business, but or actually maybe not. But yes, Reuters insisted that we must disable DTrace for their application, or they would not certify on Solaris. And this was immediately after, by the way, us doing a bake-off of Solaris versus Linux, which was actually Spark versus x86. And then to really add insult to injury, as it turns out, it was unoptimized on Spark and optimized on x86. Like, we really cannot win this one. We can't win even Spark versus x86. We definitely cannot win this if this is unoptimized. Anyway, it was bad. But no, we can't recompile it. That's changing the rules. Sorry. I'm like, oh god. And then we were like, and by the way, then we showed them DTrace, and they were upset about DTrace, which was the first time that had ever happened. I think, Adam. I don't think that happened.
Certainly, first I knew of. Yeah, no, that was early days of DTrace and early days of folks getting upset. I think there was some upset that I hear about from time to time at Apple about it being too transparent, perhaps, but they've kept it in, which I'm delighted and a little bit surprised that it's stuck for as long as it has.
I feel like you have to turn on.
Yeah. You have to disable safety. You have
to disable safety. That's right. That's the one. Yeah.
Right. Which and then the other, we had DTrace definitely got some attention from other folks that either wanted to partner with us and there's this IBM meeting that I feel we should get on the record. This legendary IBM meeting that I was not in. Yeah,
I mean this was, I think it was like the IBM Tools Group, like Rational. Was that an IBM product?
Oh, anyway. Rational Rose. This is like the Rational Rose acquisition.
Yeah, right. And so some of these folks come to Building 17, now Facebook Meta, but then Sun, and want to. You ever been in these meetings where you're not really sure what the outcome that anyone has in mind was? So anyway, we were there listening, and the most memorable thing about this meeting was a guy from IBM. They rolled about 6 or 7 deep. A guy from IBM, as our colleague Mike was presenting, slowly and obviously falling asleep and snoring, and Mike and me
snoring.
Oh, yeah, like loudly snoring, and then Mike and me doing everything we could not to make eye contact with each other, knowing that we would come completely unglued if we did. And then the program manager in charge on the IBM side, interrupting and saying, "Hey, Tim, can you wake up John, please?" And John waking up,
like, oh god, it always falls to me to wake this guy's always startled when I wake him up.
Getting up, he startles, and I swear to God, wakes up and shouts, "Solaris 9!" And Mike and I could not get out of that room fast enough, and just had giggle fits for about 30 minutes after that.
So, and unfortunately, I was not in this. This meeting only exists in my mind in your retelling, but it's very vivid. I really feel like I was in the room. I just love the Solaris 9 being.
Oh my goodness! I don't know what dream he was having. What beautiful dream about the completeness of the SVR4 vision, but.
Well, and I'm a sleep talker too, so I get always definitely don't let me go. Like if I drift off in a meeting, just wheel me on the street. Would you mind? Just at that point.
Yeah,
do us all a favor. Yeah, we that'll be one of the DTrace at 40. The DTrace at 70. Well, and so then I just want to. I know we've gone super long here, and I want to be mindful of time and your time, especially the things that we got especially right or especially wrong. I don't know that we actually got any. Yeah.
So, I mean, on especially wrong, I don't think especially wrong, but there were some CVEs here and there. But I do think you either die the hero or live long enough to see the CVEs. So
I'm grateful for those CVEs, actually. Those CVEs were extremely helpful for me because they were eye-opening with respect to C and the integer unsafety of C.
That's right.
I feel like we should use Ben. Ben, what was his surname? Ben, the guy that
Murphy?
Found Murphy. Ben Murphy. That's right.
Yeah,
found the 8 integer things or whatever at the time. He was fun to work with.
He was. I think he came to DTrace.com 2016, didn't he? I think we had him.
I think so. Yeah.
And I think I didn't really appreciate how much of that vulnerability. Finding those kind of vulnerabilities is a lot more perspiration. It was not like He wasn't doing. He was just like banging on the thing over and over and over again in
I
weird
liked
ways.
that we asked him a question about some aspect of, like, it seemed like it would be obvious that he would have understood this fully in order to be able to find the problems that he found. He's like, the what now?
He's like, I don't know.
like,
I've got no idea what you're talking about.
I just found the bugs. I don't know how it works. It's like, that's amazing. He's some
It
kind
was
of
amazing.
CVE locating savant. Like, yeah.
So there's a bunch of work that we didn't do that I'm grateful of. Like we didn't kind of create a JIT execution virtual machine for decode. There's a bunch of stuff that like seemed like obvious next steps that we didn't take out of skepticism or laziness or waiting to see if it was an actual problem. I'm grateful for a lot of those, but I think mostly USDT turned out to be an extremely happy accident where, you know, solving Plockstat turned out to be the gateway to let all languages participate in this statically defined tracing. I feel like that was just total happenstance and very fortunate.
Also, is-enabled probes were a huge breakthrough.
Oh, yeah, is-enabled probes. This is one where we generated some code to say, well, if the probe's enabled, then slap down a 1, otherwise leave it as a 0. So kind of very hacky, but allowed us to do tons of stuff where otherwise prohibitively expensive operations, just couldn't, we wouldn't design the tracing for it, but then allowed it to pull all of that out of lines. That was very fortunate as well. Agreed, Brian. But how about for you? Any missteps or any ones that you feel like we really nailed?
Well, so I think is-enabled probes. I definitely, I've always told people, like, that back when we were wanting the patent ideas, and I think that like we're kind of past software patents completely. But I'd always tell people that, like, if you can't remember where you were when you thought of it or when someone told you about it, it's not patentable because it's not. It was obvious effectively to your doppelganger, and is-enabled probes were not that. Like, I know exactly where I was when you and I were talking.
Okay, my regret on those is that the name sucks, and I have never thought of a better name for that thing. And
I feel like that means it doesn't suck. Like,
yeah, I think it doesn't. Yeah, I feel it's like society is to blame.
It's like it's been 20 years and you haven't been able to find a better word. I think it's probably a pretty good word.
Fine, nailed it.
Yeah, and so no, I think is-enabled probes are amazing, and again, I think that was a great. Adam, I remember the phone conversation in which that one came out. I think it was like that was. I feel like that was both of us. Is that correct? I don't know. Am I overstating?
I might give you no. I think if I'm going to take credit for USDT, and I remember where I was, which was the People's Republic of China. But I'll give you at the 2003
Sun Network,
Shanghai,
at the
Sun Network or whatever.
When we were sharing a hotel room, strangely, not to make it weird.
Yeah, no, I mean, sure.
Out of our own sense of like dutiful thriftiness to our corporate overlords, we were sharing a hotel room, and I just remember you had I remember your line when there was like, it was just like Shanghai 2003. Shanghai is just exploding, and they had for a period of time had the tallest building in the world, and you had that great line. I was like, man, it looks like they had a proposal and they had 3 different architecture firms have 3 different skyscraper proposals, and they're like, you know what? Just build all of them.
Yeah. That's what it felt like at the time. Every direction you looked was like construction cranes everywhere, as far as the eye can see.
Totally.
Yeah.
So I remember but I also remember when we were grappling with a really inside baseball DTrace problem. So one of the things that I did that I thought was really interesting that the world does not care about is this idea of interface stability on probes.
That's right.
And
we really thought that was going to be a big deal, in part because
it is a big deal. Goddammit,
it was a huge deal. The world is
wrong.
No, it's at Sun because we were running binaries that had been compiled 85 years ago for the Jacobian loom or whatever. It was really important to us to define interface stability. So and you're right that so we made it so that your programs could articulate their associated stability. Fast FBT probes were lower stability. Syscall probes were more stable. That kind of thing.
No, but I feel like this is still actually important today. I know that we don't.
It is important.
It's important to 8 people or whatever. But it is it is important.
6 of whom are here.
Well, something that I think
are trying to deal with their audio right now.
Something I think we need more of, right, is library interfaces into DTrace to build tools like Lockstat.
Totally.
Like, but rather than have to like post process quite so much text to fish things back out, right? Like we could have more typed programmatic access to the swapped out buffers or whatever, and I feel like, that at that point, the stability stuff would become extremely critical to like those programs that are trying to run against
Totally.
a set of probes and providers and stuff.
So a couple things on the interface stability. One is, so Adam, just like leading up to something we did right that you may actually, maybe you're even forgetting about this, that we were grappling with how to deal with stability on a probe by probe basis.
I do remember this, yeah.
And it was just thorny. And
it was thorny, and there were like literally, I mean, this was before PID provider when there were like bajillions of probes, but there were already like tens of thousands of probes that felt extremely unwieldy.
And your question / observation was, maybe we should force the interface stability to be associated with the provider, not the probe.
See, I associated that moment with the moment that you and Mike both looked at me and thought, you know what, this kid isn't useless.
This kid might have
I sort of asked what I thought was a sort of, I don't know, maybe this is a good question, and you guys just riffed on it. And I think I barely kept up with where the conversation went from there. But
I think I have said something important and valuable, but I'm not
right. I'm going to go back to sleep. Solaris 9.
No, that was a super important observation, because then it was like, oh yes, that's how we can go do this. I definitely remember that. Like, this is and I also remember like we had a couple things like this where it's like, all right, we're going to do this for now, and then we'll have to go revisit this later. But then we got a bunch of things like that we never revisited, like the jitting. I mean, we never revisited because we didn't really have to. So that was really important. And then I think it also has to be said that the way we went to the architectural review committee at Sun, I think we and I know we're long here, but we've got to regale with some quick PSARC tales. This is so PSARC was the architectural review committee inside of Sun, and this is where you would kind of sit behind this kind of council of elders and present the work that you are doing. And PSARC, there were valuable things to PSARC, but PSARC also, it was comprised of folks whose job was PSARC, which was a real problem. And this is one of the things, I don't know your take is on this, but I think like when you have people whose only job is the review of other software, it's really tough to stay, I think, current and relevant, and it's easy to lose that.
Totally. I mean, and then the incentive becomes, the only way you add value is by extracting your pound of flesh. Because otherwise you're just you're just rubber stamping everything.
Right. And so there was this issue of like, how are you all going to deal with PSARC? You've got this like large thing that you've clearly thought a lot about. And I think that this is really due to Mike. This was kind of a masterstroke of getting to PSARC. Like, okay, what we're going to do is we're going to split this into multiple cases. And we are going to have the DTrace case is going to be all of DTrace except for the providers. And because what we predicted rightly was that everybody was going to want to really talk about how the system was instrumented, and not what we felt was actually in many ways the more important thing from an interface perspective, which is this broader system that's consuming the actual tracing information. So we split this, and we had all of the providers in a separate case. And I mean, Adam, do you remember this? Like this strategy worked to perfection, because what we knew is like ultimately you want to run out the shot clock with PSARC. That's ultimately what you're trying to do. And because ultimately if you run out the shot clock, they're going to approve you. So we get to this and do you remember bringing the DTrace documentation into PSARC?
No, I don't.
Oh God, it was so great. It was like, I feel it's like one of these moments from like Aaron Brockovich or whatever. Like, you know what I mean? We're like, they're kind of coming in with like this stack of depositions or whatever. So we're like, here's our PSARC case. Drop this box filled with manuals that we'd written on the table. We're dispensing these manuals that have where we've documented this entire facility that we have done all without PSARC pre-approval. And sure enough, in the discussions, all they want to talk about are the providers. And what we would do just brilliantly, I remember like letting people kind of pontificate for a while and letting them expand on this and be like, okay, well, that's very interesting, but that's actually not in this case. That's in the next case. And I now see that you've used 3 minutes and 13 seconds on that. Next question. And they kept doing this. And of course, it's like ultimately there was too much for them to meaningfully understand. And none of them were actually using DTrace themselves. They didn't really appreciate it. And then we get to, and they approve it, which is just, and also we also were encouraging them when they wanted to waste time on. And you remember like they wanted to talk about the definition of standard C? Do you remember this?
Yes, I do. Right. In particular, you mean like the header file definition of standard C? Because like we were sort of like in header files in some cases. So the other brilliant move that Mike did on this case and many others was to ask a question whose answer we did not give a shit about.
Yes.
So it gave them an opportunity to bike shed, ad nauseum, and then give us an answer that either was obvious on its face and we knew how it was going to go, or it's like, fine, don't care. You tell me.
You would think that they would see through this, but no. As it turns out, this is just such an easy kind of con about like if you take someone who's like has got some predilection to bike shedding and you put a bike sheddable question in front of them, like they're basically going to take the bait, and they basically did, and they spent the entire time. And I remember thinking like they do not understand what we built at all, and it's like let them cook, like let them. They're going because as soon as like they start feuding among themselves, like this is what we need. This is the way you go like from taking a minute off the shot clock to taking 35 minutes off the shot clock is by having these them go at it. So they pass the DTrace case without so much as a like sentence of discussion on this like massive stuff. And in particular, we had made interface stability, kind of PSARC interface stability, we had kind of elevated in this case in a way that we thought was like going to be really controversial, but no one had paid any attention to it. So then we get to the first provider case, and now they've kind of exhausted themselves talking about the way the system is instrumented when they weren't supposed to be talking about it. And in particular, and remember, all those provider cases would have the matrix of interface stability for the provider.
That's right.
And they're like, what the hell is this? Like, that is the interface stability of the provider. It's like, well, okay, we're not, you can't like programmatically define interface stability. It's like, actually, if you go back to the case that you just proved,
you already have.
And that was definitely,
and it was stable, so you can't take it back.
It was stable, so you can't take it back. It really was. It was just like, it did feel like we had defeated PSARC, and the
dominoes fell like a house of cards.
Exactly. It felt like a kind of a Kaiser's to say moment. Anyway, it was that was. Sorry, Adam. I had to.
That's great.
I think that the interface stability per provider was great. I think interface stability is, as Josh kind of alluding to, one of these things that's really important that people don't understand. Anonymous tracing has been huge. I think postmortem tracing has been huge. Speculative tracing. I mean, I love the fact that this is still something that we're still using. And we're still using it, still evolving, still bringing in new folks, still lighting up parts of the system that were previously unseen. And boy, how lucky are we to have been able to participate in something that has that kind of staying power. Is really terrific. It really feels.
I mean, I think when we were working on it before we had shipped to any customers, I really thought this was going to be something that really was relevant only within those four walls. That we were going to use it in the kernel group. Maybe some folks at Sun were going to use it, but and that was going to be worth it. Like that was going to be an unquestionable value. But the fact that customers got into it, that it's been ported, didn't see it coming, and as you say, incredibly grateful that all those things happened.
And grateful that honestly, I also have to say grateful to Sun and honestly Jonathan Schwartz in particular for open sourcing it. I think if it had gone down with the ship, we wouldn't be using it today. That's what it boils down to. So
absolutely
grateful for that. And I grateful that we're here. DTrace at 20, man. It's
who would have thunk it?
Yeah, who would have thunk it? And still using it, still in daily use. So
yeah.
Josh, thank you for joining us.
And most welcome.
For that Hungry Jacks was not just a fever dream, that it actually happened.
Yeah. And
thank you all for, again, really appreciate everyone and the community and look forward to an awesome DTrace.com for 2024. It's going to be great. All right, Adam, thank you very much. I'm glad we did this. And I thank you all for joining us, and we'll see you next time. As Janet says in the chat, here's to 20 more. Thanks, everybody.
Thanks.